So yesterday we talked about, I wanted you to draw a rectangle using this picture, right? And do you agree we have 3 lines here? And who came up first? Okay, Maddox came up first, and you drew a rectangle. Do you remember where? Up top or on the bottom? On the bottom. Maddox drew a I'm going to actually use a pretty line. Let's do that. Drew a rectangle somewhere down here, right? And then somebody else came up, and you drew it up top? Yeah. I believe they drew it up top right here. And then somebody else came up.
And it was like also on the top.
And drew it. Oh, also on the top. So, and didn't we say we could sit here forever and ever and just draw lines that made rectangles? Right? And so what did we say we noticed about these lines? Did we talk about that?
They have the same slope.
They were parallel. And what did we know about parallel lines?
They have the same slope.
So that's what we're going to talk about today. I'm going to give you all a minute real quick to just watch this video for fun. And I'm going to kind of... Can you imagine the world without mathematics? Let's see what would happen if there were no parallel lines. Our streets are made of parallel lines. When 2 lines lying on the same plane do not intersect, they are known as parallel. Roads as well as railway tracks are always parallel. Y'all agree with that?
Yes.
Yeah. Mostly bridges are also parallel. Ladders as well. And then we're also going to talk about perpendicular lines. Perpendicular lines are 2 coplanar lines that intersect at a right angle at 90 degrees. So what would happen if there were no perpendicular lines?
There wouldn't be any, like, it'd just be...
It'd be weird, right? Roads are perpendicular for smooth flow of traffic. Buildings are straight and balanced due to the perpendicular lines, the pillars. And we're going to stop because I don't want to do that. What I do want to do is I want you to look around the room and just think about it. Do you see a set of parallel lines anywhere?
Yeah.
Think about it. Think about it. Find it. Do you see a set of perpendicular lines anywhere? Turn and talk to the person next to you or around you, group of 3 if you need to, about where you see each of them. You got 30 seconds.
Yeah, and
Where? Go with Marley. Go with Marley. Yeah. And then go with Marley and you can talk.
I like the other.
That thing right there? The charger?
All right. 5, 4. All right. Does anybody want to raise their... I don't know why I have this up. Anybody want to raise their hand and volunteer and give me an example of parallel lines? Jordan, give me one.
The L.
The L. You know, every class is mentioned. The letter L is literally perpendicular. Do we agree?
Yeah.
Perfect. All right, Lily. Yep, there we go. And the table of contents that we're going to do later, that is a perpendicular line. Braxton.
The little grid chart over there.
The little grid chart. Honestly, every type of grid that we deal with in this class, do you agree all our graphs are parallel and perpendicular lines? Yep. Logan, were you raising your hand? Do you want to just tell me anyways?
I don't know. The calendar. Right here.
The calendar. The calendar's full of parallel and perpendicular lines. Anybody else? Look at your computers.
All computers are.
What if we didn't have parallel and perpendicular lines?
It wouldn't be like a top everything.
Yeah, can you imagine your screen being like, would we be able to really read it and like understand what's on our computer if our screen was like crazy? Look at the keyboard. The keyboard has a bunch of parallel lines. Do you agree? And can you imagine if they weren't parallel line and we had to like do our hands like sideways or something like that? So have you ever said in a class, when am I ever going to use this outside of this class? Okay. You might not graph parallel lines outside of this class. You might, but you might not. But you're going to see and deal with parallel lines all the time. Look at the bookshelf. parallel line. Like the foundation of building anything has to have parallel and perpendicular lines. That's like the basics of all creating things, right? Y'all agree? Okay, so we already did slope. Let's go to our flap and let's do the parallel lines flap. So open up to your second flap because we already did slope yesterday, right?
No.
Did y'all get this paper yesterday? Y'all didn't get it? Okay. Okay, we did slope yesterday, so now we are gonna do parallel lines. So, parallel lines have the same slope, so can everybody please write that at the top? And then right next to it, if you can just draw two sets of parallel lines like this with the arrows. FYI, in this class, you cannot assume lines are parallel unless we tell you they are, or unless they have the same slope. So in this class, we notate that by drawing an extra set of arrows in the middle. If you ever see an extra set of arrows in the middle of a line, that means those two lines are parallel.
What if there's like multiple parallel lines? Would they have more arrows?
Yep, like if there was another one, it would have another arrow on it. Yep. And then the other thing is mathematicians are a little bit lazy when it comes to writing. So instead of writing the word parallel, you are often going to see me, because I am a mathematician, just write two L's. That symbol, two lines, that symbol means parallel. Okay? So example 1 and example 2, I'm going to give you 1 minute. I would like you to determine if these lines are parallel, perpendicular, or neither. And just think to yourself, Braxton. Think to yourself. The ones on top, yes.
Wait, the examples or?
Just example 1, example 2.
Oh.
All right, example 1. What is the first slope given? 3. Well, what's my slope though? Just 3. What's the slope of the second line? 3. Are these parallel, perpendicular, or neither?
Parallel.
Why?
Because they have the same slope.
So on your quiz and your test, you're going to have to write it and explain why. So for this one, we are going to say these equations are, and again, I'm a little bit lazy, so I'm just going to do parallel like that. Because, why?
Because they both have the same slope.
They have the same slope. What about number 2?
Parallel.
Why?
Because they both have the same slope.
Are you sure?
Yeah.
But 4 is right here.
So,
It has to be with x. So they both have a slope of 1/3. So what am I going to write?
These equations are parallel.
What questions can I answer? You're going to have to be able to look at equations, graphs, and tables and determine if they're parallel, perpendicular, or neither. Slide on up to example 3. Example 3 is different. Now I give you one graph. Who would like to read what it's asking for me to find? Jordan?
Given the graph below, find the slope of the function that would be parallel.
Okay. Anytime you see the word parallel, I would like you to write same slope. And I know some of you are like, why do I need to write it? Obviously. Yes, but when I start adding parallel, perpendicular, when I start adding in other words, it gets confusing. So when you see parallel, I want you to write same slope. How do I find the slope here?
Rise over run.
Rise over run. And by the way, if I haven't said this, I know some of us know this. And I know you're like, why are the notes so detailed? For 2 reasons. One, when you're off on your own, the more detail you write in the notes, it'll help you if you get confused. I don't necessarily need you to write this when you're doing the worksheet. Like rise over run. Does that make sense what I'm saying? But I want you to write them in their notes so that you can always look back and understand what you were doing. Okay. Up until today, I always gave you what you needed for rise over run. What do I got to do to find the slope here?
Find the 2 points.
Choose 2 points. And then rise over run, go up and over. Does it matter what 2 points I choose? No. Which ones do y'all see? I heard somebody say -1. What else?
3. I mean, 2.
2, 2. And then do your triangle like we've been doing. Am I going at an okay pace?
Mm-hmm.
If I'm going too slow, let me know. I meant too fast. I'm also recording, so I gotta like. How much am I rising?
3.
How much am I running? So what is my slope? What's 3 divided by 2?
1.15.
Okay, but do I ever want a decimal for slope?
No.
No.
3 over 2.
So leave it 3 over 2. So I'm going to write right here because the question is asking me to find the slope of a function. So I would say a function parallel has a slope of what?
3 over 2.
Why 3 over 2?
Because it's same slope.
Same slope. Example 4. Somebody else who would like to read. Thank you. Somebody read.
Can I read?
No, somebody new.
I'll do it.
Oh.
Oh, no, you got it, man.
For example 4,
Mm-hmm.
given the equation below, find the slope of a function that would be parallel.
Perfect. Can I look at this and know the slope?
Yes. No.
Yeah.
Yes. No. You have to subtract it.
Technically, no. So I know some of you can look at it and know to subtract right off the bat. However, can I look at an equation that's not y equals and know the slope? I have to get it in y equals. So how can I get y by itself? And bring everything down. Now can I look at this? We shouldn't be on our computers. We should be on notes. Now can I look at this? What is my slope?
-2.
So how do I answer this question?
This slope is negative. Or single function parallel would be. Write this like every time, like on a worksheet.
So yes and no. I want you to, again, I'm making you write it for your notes. Most of the time, honestly, you're either going to have to do a multiple choice or you're going to be graphing it. Yeah. That makes sense. Or it'll be like a fill in the blank. The function has like it'll be fill in the blank. All right. Are we okay with parallel? Do I have any questions about parallel lines? Parallel lines have the
Same slope.
everybody. Parallel lines have the
Same
Slow.
perfect. All right, last flap. 4 problems left. We get out at what time? Okay. Now for perpendicular. This is the one that everybody forgets about. Poor perpendicular. What are perpendicular lines?
They make right angles.
Okay, so perpendicular, everybody's been telling me that perpendicular lines can have the same y-intercept, but they don't have to. But like parallel lines can't have the same y-intercept.
Same stuff is different, like you get positive. Like if it's positive, then the
Same slope, different. Yeah, what you said.
Okay, so you're close, not correct, but you're close.
It's the slope is flipped, and then it's a positive.
There we go. Okay, 2 things. 1, these are not perpendicular lines. Perpendicular lines are not lines that just cross. You have to be specific. They have to make the right angle. Okay? And do y'all agree perpendicular is a really long word?
yes.
Yes. Do you agree that I'm a little bit lazy when it comes to writing? So the symbol, you're like, I don't want to admit that. But yes, the symbol for perpendicular is an upside down capital T. So when you see this symbol, that means perpendicular. And perpendiculars lines have the, somebody already said it, they have the opposite, which means you're going to change the sign. Does anybody remember what the other word? Opposite.
Opposite. And not in-
Slope is the last word.
Wait.
There's another word, then opposite.
Right.
What does it start with?
Reciprocal.
Reciprocal.
Opposite reciprocal. Have y'all ever seen that word? Okay. So everybody say reciprocal.
Reciprocal.
Say it again. Reciprocal.
Reciprocal.
Reciprocal means to flip the fraction. So parallel, you just took the same number, correct? Perpendicular, we're going to do the opposite reciprocal. We are going to flip and change. Off to the side, I want you to do this with me. Write it down. We are going to do 5 examples. We are going to find the opposite reciprocal of 5 different numbers. What is the opposite reciprocal of 2/3?
3/2.
So we got to flip and change the sign. This one's positive. What's this going to become? So the opposite reciprocal of 2/3 is -3/2. Does that make sense? What about the opposite reciprocal of -4/5? Flip it and change the sign. It's negative. It's going to become positive 5/4. Are we cool with that? Opposite reciprocals are real basic whenever you already have a fraction. But what if I don't have a fraction?
You just make it one.
So,
Wait, I have a fraction. You put the 1 on top and then over, yeah, and then 1/3.
correct. If it's not a fraction, you can make it a fraction by putting it over 1 and then flip it. And it was negative, so it's going to become. Does that make sense?
Yeah.
Okay. What about positive 1/8? What's the opposite reciprocal of positive 1/8?
8/1.
Negative, no, you're right. -8/1. Flip it and make it negative. However, what's 8 divided by 1? 8. If you left it 8/1, there's nothing wrong with that. Okay? Okay, here's one that stumps everybody. Y'all ready? What is the opposite reciprocal of 1?
Negative 1 over 1.
Or negative one.
Negative 1.
Or 1.
Is it not negative
Yeah,
1?
negative 1 over 1.
Negative one or negative
So do you agree 1 negative fraction is 1? If you flip 1 over 1, do you agree it stays the same?
Uh-huh.
But since this one positive, what does it change to?
Negative.
Negative. I kept getting 1/2 today. And I don't know where they're getting the 2 from. It happens. I also kept getting 0. It's just negative 1. Did you write all those down?
Yes.
Okay. Now I'm going to give you 1 minute. I would like you to do example 1 and example 2. Determine if these are parallel, perpendicular, or neither. And then I want you to write an equation like we did up here. These equations are what, because why? Go. Do you need a little bit more time? A minute?
Oh, 30
30 seconds. Okay. I'm going to go over it. So if you don't finish, you'll have time.
We're doing all.
We will, yeah. But don't go ahead yet. Just 1 and 2. Just 1 and 2 right now. For the first one, did y'all get 1/2 as the slope?
Uh-huh.
Are they the same? Are these two slopes the same?
No.
No. So is it parallel? No. Okay. So 1/2, what is the opposite reciprocal of 1/2?
Negative 2.
Do y'all agree it would be -2 over 1,
Yes.
which would be
Negative 2.
-2? Is that what we got right there?
Uh-huh.
So therefore, these equations are
Perpendicular.
perpendicular because, what did you write?
They have the opposite reciprocal.
They have opposite reciprocal.
And same slope.
Same slope. Oh, wait.
It says at the top, the opposite reciprocal
Slope.
slope. You're reciprocal, Jordan.
Reciprocal?
Because they have opposite reciprocal slopes. And I'm going to be lazy and put op. Okay, what about the next one? -5. How do I flip and change?
Positive.
Positive 1 over 5. So is it opposite reciprocal? Yup.
Is there a sign for neither?
You would just write neither. And I want to talk about if it's neither, you have to write neither because the slopes are not the same and not opposite reciprocals. Does that make sense? Okay. Any questions? All right, last two, and then we're done for today. Given the graphs below, find the slope of the function that would be perpendicular. Again, you see this word perpendicular. I would like you to write flip and change. You're writing this with me, please. Flip and change. How do I find the slope here? Rise over run. And y'all, if they have a perfect x-intercept, I would choose the x and y-intercept. It's what? It's 2. Why is it 2?
The slope is 2.
It goes up 2, right 1. Up 2, right 1. Now, do I want the same slope? Do I want parallel? So what is the opposite reciprocal of 2 over 1? So you would say a function perpendicular has a slope of -1/2. You have to flip it and change it. This line is positive, so my perpendicular would be negative. By the way, for perpendicular, it doesn't matter what the y-intercept is. For parallel, you can't have the same y-intercept because otherwise it'd be the same line. You do number 4. Go.
Oh, are we keeping it a fraction?
Keep it a fraction.
Oh,
Always don't ever give me slopes that are decimals.
okay.
Yeah.
No,
Keep,
I'm saying like
you can reduce it.
we can make it a whole number.
Yes.
Oh, okay.
Yes. But be careful. Make sure you're answering the question. Did I collect y'all's warm-ups?
No.
Okay, I'll come collect them.
For this one, it's gonna be
Yes.
-9, so it'll be a positive. Okay.
Correct. So class a little bit better pace for y'all with that. So class a little bit better pace for y'all. Thank Coach Schneider because she's the one that emailed me and let me know. So okay, how many of you did carrots? How many of y'all did carrots on this one? How many of y'all did slope formula on this one? 2, 1, okay. Okay, so look up, please. I know y'all got it, but I want to make sure. Right here, this is your delta y. Oh, let's read it first. Find the slope of the function that would be perpendicular. Again, I'm going to write flip and change because I just want to remind myself it's not the same. How do you get from -9 to -1?
+8.
How do you get from 4 to 2? And remember, to find slope, we do delta y, you should not be on your computer, over delta x. My delta y is 8. My delta x is -2. What does that give me, boys? -4. Is that my answer?
No.
Why? Find the opposite reciprocal slope by doing over 1, flip it, and it's going to become +1/4. So this would say a function perpendicular has a slope of 1/4. And we are done. In just a second. What questions do I have? Okay. Big thing I need you to remember. Parallel lines have the same slope. Perpendicular lines have the
Opposite reciprocal slope.
opposite reciprocal slope, which means flip and good job. All right. Let me pause.